Okay, we are going to print the elements of an array in the decreasing frequency in which those elements appear in the array. If two numbers have the same frequency, then we're going to print the one which came first. So an example of this would be 2, 5, 2, 8, 5, 6, 8, and 8. Okay, and then for this one, the output would then be 8, 8, 8, 2, 2, 5, 5, and 6. And so the way that we're going to tackle this is by doing kind of 3 steps. We're going to add these things to a map or a dictionary. And the key will be the elements, and the value will store the number of occurrences and the order in which we saw them. And then we're going to add the map contents to a priority queue or a max heap, which will then put them in the order that we want to see them, and it will prioritize based on the comparator that we set up, which will tell it, okay, first we want to look at who has the most occurrences, and in the case of a tie, we want to go and look at the order in which we saw it. And then the third thing that we're going to do is dequeue that priority queue and print the elements from queue. Okay. So the first thing that needs to happen is we're going to make a class so that we can store the object as the value. So we're going to make a class. We'll just call it numinfo. And it's going to implement iComparable, which let me just make a little room. It's going to take a numinfo. Okay, and then what iComparable will do, it has a method called compare_to, and priority queue looks for that method and uses that in order to prioritize how to sort. So first things first, we're going to want to have some places to store things. We're going to store the number. We're going to store the number of occurrences. And actually, we're going to need some getters and setters with these things. And then the last thing we're going to store is the order in which we saw it. Okay, and then we can make a little function like, we'll call it like add occurrences. And all it's going to do is return occurrences plus 1. Okay. And then we also need to write our compare_to function. So, and that's going to return an int that's going to tell the priority queue how to prioritize. So it will return either a 1 or a -1 in this scenario. It could return 0 if we set it up to, but we do not need to implement that. So that's going to take numinfo, and we'll just call it other. Okay, so first things first, we're going to, we need to compare them. So let's start out if this occurrence is greater than other occurrence, then we know that we need to return -1. And the way you set up what it's going to return is based on how you want to prioritize, if you want it to be a min heap or a max heap and what's important to you. If other occurrence is greater than this occurrence, then we want to return 1. And then we want to go into, if neither of those are true, then it means that the occurrences are equal. So we want to start looking at if other, let's go ahead and start with this so that I stay organized. If this dot order is greater than the others order, then we're looking at returning 1. In this case, we want to actually get where the order is smaller is more important to us. So that's important to do. And then if other dot order is greater than this dot order, then we will return -1. And I think that we'll go ahead and have a return 0 because I have a feeling the compiler is not going to like that all of those returns are inside if statements. That will never hit because one of these has to be true. Either it's going to be greater than or it's going to be less than. So there we go. We don't need, oops. Okay, so that is our numinfo class, and that is going to weigh what is stored. An object of that is going to be stored for the value for each of our keys. So let's go ahead and get into the algorithm that we're going to use, our main algorithm. So we've got let's go ahead and make it void, and we will just print all of these right inside this function. We can just call it, I don't know, recurring nums. And it's going to take in an array of integers. I just did that backwards. Okay. All right. So, and I guess, yeah, that'll be great. And then we first want to check to make sure that our array is not empty, because then we can just throw a new exception. Array cannot be empty. Okay. Otherwise, let's go ahead and also check and see if array is at 1, because then we can just return, we can just print if that happens. It's really an else if. Else if array.length is 1, we would just write out array at 0. And then otherwise we go into our algorithm. So the first thing we want to do is add to dictionary. So let's go ahead and make a dictionary. And it's going to have an int for the key, and it's going to have numinfo for the value. And we'll just call it map. and that's a new dictionary of int and num info. Okay. And then we will have to, I think that's it. Then we can just go into our for loop. Oh, we do need a variable for our order to kind of keep track, and it'll start at 1. This is going to tell us, okay, I saw this element first, then second, then third, and so on. And so we need to keep track of that so we can add it into our object. And then we also have we'll start our for loop. And okay, so first things first, let's make a new and let's instantiate num info. To store our data in. So the first thing we want to do, there's 2 ways that will happen. Either it's in the map or it's not in the map yet. So first, let's assume it's not in the map. If it's not in the map, so that's contains key. Let's see, if not map.contains key at array at I, then we know we need to add it to the map. So first we want to store the information that we want. Info.number equals array at I, info dot occurrences. This is our first time storing it, so it'll just be 1. Info dot order will be order. So it's starting at 1 and it'll increase every time it sees a new number. And then we needed to add it to our map. Map.add. And we're sending it array at I and info. Okay, and then order plus plus, we can't forget that because we need to keep track for the next one. And I think that'll do it. So otherwise, if it already is in the map, then we just want to map at array of I equal, or no, actually we have a function, so we just say dot add occurrences. Okay, and then that should do it for our for loop. That should add everything into our dictionary. And then we want to, after that, we're going on to add to the priority queue. So let's go ahead and make our priority queue. C# does not have a built-in priority queue like Java does, so you have to just download like a NuGet packet into the project, which is no big deal. It works the same way once you load it into the system, and there's lots of different choices for that. Okay, so we've got our priority queue, and then we're going to just loop through the map. So for each item in the map, and then we're just going to say PQ dot in queue. We want the value of the item in there. Okay. All right, so that takes care of that, and then it's time to DQ. And as I said, priority queue is going to automatically go and find the compare to function behind the scenes, and it's going to order everything in the way that we've specified, which what we want is for the most frequently occurring items to be first, and then the also ordered by the order in which we saw them in cases of duplicate occurrence numbers. So that will take care of that. So then all we have to do now is to just DQ. And in order to do that, we will we'll get an instance to load things into. Okay, and then we're going to be using a for loop. I is less than basically however many elements. We can use the map count. We can find out how many elements are in the priority queue if you want. Either is fine. And then I plus plus. And in a hopeful world, that map count is going to be less elements than n, which means we won't have gone through the priority queue, DQ, and NQ as many times as we did for loading the hash. That's our hope in the best case. And worst case, we would be going through n if all of our items were only occurring one time each. So we go through our for loop, and first we go data dot DQ, and then what we want to do is that's going to give us all of the information, and what we need to do is print only one at a time, knowing that there's multiple occurrences within that data item that we need to keep track of. So while data dot occurrences is greater than 0, we're going to add them into the array, and actually we need to keep track of the location in the array that we want to put this. It's not as simple as just going through I times, because we don't know how many of each number it's going to see. It's going to actually change more often than as we loop through I. So array.placement equals data.number. Then we want to do placement plus plus for the next position. And we want to decrement the number of occurrences. Okay, and that should do it for that while loop and the for loop. That should load that up. And I just realized I don't even want to load it right into that array. I'm actually just going to print it, which means we don't need a placement. Or actually, maybe I will go ahead and load it in the array. I'm not making an extra array. This is the same array that we came in with. I'm just overwriting the data since we know it's the exact same number of items going in that were originally in there. So we will go ahead and keep placement, because this way we've got our array saved just in case there was something that we wanted to do with it later. But I'm going to go ahead and print right away inside of our while loop so that we can save a loop later. Okay, so we're going to write, we can actually just write the data number within this. I would rather put this kind of right above, right under where I'm adding to the array, but this is fine for now. Data.number, and actually let's put a little space in there so that we can get the numbers more and a better printout so that we can actually read them. So that'll write everything to the console in the order in which we want them to. Then we can close our while loop. We can then close our for loop. And we also can close our else and our function. Okay, so that should be everything that we need. So now we can go through and we can test this. Let me try to get this a good size so that we can see everything and still test. Okay. So first things first, we want to add to the dictionary is what we're doing. So we come in here and first we look at our array, and actually let me rewrite the array so we can see it better. 2, 5, 2, 8, 5, 6, 8, 8. Okay, so that's the array we're working with. And so what we want to do first is come in, is array.length equal to 0? No, it's not. Otherwise, is array.length equal to 1? No, it's not. Otherwise, we're going into our algorithm and we're creating a dictionary. So let's go ahead and make a dictionary to store our items. Here's our key, which is also the number. And our date, our value, we'll call it our value, is going to be the num info object, which we know has num, occurrences, and order. Okay, so we can kind of keep track of all of those as we go. And then we're going to have an I to keep track of and an order. Okay, so we can have I and order. All right, so let's go in here and we've got for and I equals 0, so I starts at 0. Then I is less than array.length, and we know our array is of size 8. So I'm going to put a note there. And then we have num info. So if the map does not contain array at I, and I is at 0, so if it doesn't contain 2, which it doesn't, then we go in here. So info.number equals array at I, so num equals 2. We'll just add it here. We're not adding to the dictionary yet, but just to keep it organized, we'll just put it here. Is 2. Occurrences equals 1. And order equals order. Order equals 1. And then map.add array at I and the info. So array at I is 2. And then order plus plus. So order is now 2. We skip the else because we did the if, and then we come up I plus plus. I is now 1. We go in, if, and I is and 1 is less than 8. So we come in and we say, does the map contain array at I, which is 5, and it does not. So we go in and we add the number of occurrences, and the order, which is 2. Okay, and then order plus plus. Go on out of there, skip the else. Order, and I plus plus is 2. 2 is less than 8. So we go in and we say, is array at I, which is 2, is that already in the map? And it is. So then all we have to do is go down to our else and we add an occurrence. So 2 becomes an occurrence of 2. And then we go around I plus plus. I is now 3. 3 is less than 8. So now we come in, if the map doesn't contain array at I, and I is 3, so that's 8. It does not contain 8. I forgot to put that 5 there. So we want to go in here, and info number is 8, occurrences is 1, and order is 3. And we add it to the map, and then order plus plus. Okay, and then we skip that else, I plus plus. 4 is less than 8, so we still go in. And if map doesn't contain array at I, and I is 4, so that is this 5 here, and it does contain 5, so we go down to our else statement, and we add an occurrence. So now occurrences for the value 5 is at 2, and we go I plus plus. Okay, 5 is less than 8, so we keep going, and if the map doesn't contain array at I, and I is 5, so we're at this 6, and map doesn't contain 6, so we know we need to add the number, occurrences, and the order, which is 4. Add to map, then order plus plus, and then we go around I plus plus. I is 6, 6 is less than 8. We go in, does the map contain array at I, which is this 8 here? And it does have an 8, so then we go down to our else statement, we add an occurrence. So now occurrences is equal to 2. I plus plus, come in, is 7 less than 8? Yes, it is. So we go in, if the map does not contain the key at array at I, and I is 7, and that is an 8. But 8 does contain an 8, so we do not go into that if statement, and we go down to the else, we need to add an occurrence. So we come in, and occurrences is at 8, changes to 3. Okay, and then I plus plus, I is 8, we come in, 8 is not less than 8, so we get out of this for loop, and our map is now populated. All right, so then we go down, and it's time to enqueue all of this information from the map. I'm gonna just make a little room. Okay, so we go in, and we'll just make a PQ here, and we'll go ahead and store everything kind of in a top to bottom fashion. So the things on top are the beginning of the priority queue, which will be our biggest items, or the ones that we put as priority, and it'll just kind of go down. So for each item in the map, we're going to enqueue the item's value. So we're going to go ahead and be doing what's inside this info value that we stored in the map. So first we go in, and the map is this key at 2, and the value is 2, 2, and 1. Okay, and then we go into the next one, and we're at 5, and it's 5, 2, and 2. So the priority queue will go in, and it will insert it, and then it will reheap until it gets it into the position that it wants to be. And it's using the way that we set up our compare-to function over here to determine this. So it's deciding, is this new occurrence greater than or less than the other occurrence, and so on and so forth. And it will prioritize as it heaps, or reheaps, I should say. So in this case, it's going to prioritize it to put 5, 2, and 2, because although they both have 2 occurrences, we go into a tie, and this order is greater than this order here. So we know that we want this to be second, basically. It's less priority than the first. So we go in then for the next one, because we're doing for each element, and we get to the 8, and we see 8, 3, and 3. So the priority queue is going to go in. Is it going to say, is the 3 occurrence greater than or less than this 2? And it's going to realize it's greater than, and it's going to go in, and it's going to say, is this occurrence greater than or less than this 2? And it's going to figure out it's greater than. So it's going to reheap to be a final product of 5, 2, 2, and 2, 2, 1, and then the 8, 3, 3 will be at the top. All right, so Then for each, we're still in that because there's still elements. And so we get here to the 6, and it's 6, 1, 4. The priority queue is going to look at that and see that it only has one occurrence. And after it compares everything, it's going to keep it at the bottom of the list. Okay, so now everything is in-queued into our priority queue. And now it's time to go through and dequeue and print. So we go in and we say, let's go ahead and keep track of, we have placement, we have I, we need to keep track of the data occurrences, and then we need to keep track of our array. We'll write our array down here, which is also going to be the output. So it'll be the array slash the output when we write to the console. So let's see. So to start, we go in and placement is 0, I is 0. And we first go to data.dequeue. It's going to dequeue the 8, 3, and 3. So we can keep track actually of the data if we want to. It's going to be 8, 3, and 3. And then this has now been taken out of the queue. And so we go into data occurrences, which is 3 to start. And we're looking at while data occurrence is greater than 0, which it is because it's 3. We go in and the array at placement, which is 0, equals data.number. So that's going to be the 8 first. And our console will also be writing the 8 as well. So it's kind of all at the same time, basically. Then placement plus plus, so placement becomes 1. Data occurrences minus minus, so that goes down to 2. And again, we wrote our number. We could even write it again down here for our console.write. And then we go up to the while loop, and data occurrences is now 2. 2 is greater than 0. So we go to array at placement, which is array at 1. It equals data number. So we get an 8. Placement plus plus. Placement's now 2. Data occurrences minus minus is now 1. And console.write data.number, and that's 8. Okay, and then we go through to the while loop, and 1 is still greater than 0. So array at placement, which is 2, we write the number, or we send it the number. Placement plus plus, now placement is 3. Data occurrences minus minus, it's now 0. And console.write, we get an 8. Okay, and then we go up. Data occurrences is 0. 0 is not greater than 0. So we get out of this while loop, and now I plus plus. I is 1, and the map count was 4. So we need to keep track of that. So so data.dequeue. So we're on to the next one. And let me just make some room. Since we're done dealing with this first data, we're just going to start over. Okay, and date and placement was at 3. I is 1. I is 1. Okay, so now data.dequeue, and it's going to pop off this next one, 2, 2, 1. 2, 2, 1. Okay, so data occurrences is 2. Placement's 3. I is 1. So we go in, while data occurrences is greater than 0, 2 is greater than 0, array at placement, which is 3, equals data number, which is 2. Placement plus plus, that's 4. Data occurrences minus minus, which is 1. Console.write, data number. Then we go back around, and while 1 is greater than 0, it is. Array at placement equals data number, so that's 2. Placement plus plus, that's 5. data occurrences minus minus, that's 0. Console.write 2. And we go in, and 0 is not greater than 0. So we go back, I++, I is now 2. And so data.deque, start these over. And this had been popped off. So now data is 5, 2, and 2. Data occurrences is 2. So while data occurrences, which is 2, is greater than 0, array placement is 5. So array at 5, which we are 1, 0, 1, 2, 3, 4, and 5, is going to be data number, which is 5. Placement plus plus, placement becomes 6. Data occurrences minus minus, that's 1. Console.write data.number, which is 5. And back through the while loop. So while data occurrences and 1 is greater than 0, array at placement, data number, that's 5. Placement plus plus is 7. And data occurrences minus minus is 0. And then console.write 5. Okay, now we go back. 0 is not greater than 0, so we go back to our for loop, I++. I is 3, 3 is less than 4. Okay, and then we're going to end up dequeuing again. We just did that 5. And we'll clean this up a little bit. All right. So data.deque, 6, 1, and 4. And the occurrences is 1. Okay, so we go in. Well, 1 is greater than 0 because data occurrences is 1. Array at placement, which is 7. We're going to put data.number, which is 6. Placement plus plus, that becomes 8. And data occurrences minus minus, that's 0. And console.write data.number. And then we go up, and while data occurrences is greater than 0, 0 is not greater than 0. So we get out of that. We go in, I++, I is 4. 4 is not less than 4, which was our map count. So we're done with our for loop, which means that we have now ended our program, so we can check and see how we did. So our output was 888222556, and it looks like our expected output is 888222556. So that looks to be good, and it looks like this would have a time complexity of, let's see, we go through the entire array to add it into the dictionary, so that is O of n. And then when you go through and enqueue into a priority queue, that is n log n, O of n log n. And then when we're going to go through one last time and dequeue, and that is an n, so it would be O of 2n. So we can just go ahead and change that to a 2. O of 2n plus O of n log n would be our time complexity.